Hello students, welcome to today's lecture on problem solving with programming in C. In our previous class, we have discussed about what is structured programming and how functions helps us in implementing that structured programming concepts in C language. Today also, we will continue with the functions related concepts to understand how well we can use the functions in order to implement that structured programming and modular programming in an efficient manner. So today our topic is parameter passing mechanisms. What is meant by this parameter passing mechanism? So we know that when we define functions, we declare formal parameters, and then when we call the function, we use actual parameters. Okay. And this topic, parameter passing mechanisms, talks about how we can send the parameters, that is actual parameters, through the calling function, okay, and then through the called function, and then how these parameters are actually handled in the called function. Okay. So how these parameters, the actual parameters are sent, and how these actual parameters handled by using the formal parameters. So this is about the parameter passing mechanisms. In a little while, we will see how we can, what are the different ways of sending parameters to a function when we call it. So always remember that parameters are passed while calling the function. Okay, so there are several ways of sending these parameters while calling the function, and with respect to that, you need to handle those parameters in the function definition also. Okay, so let us start with the types of parameter passing mechanisms. There are two types of parameter passing mechanisms available in C language, namely call by value mechanism, and the second one is call by address mechanism. This is also termed as a call by reference mechanism by some authors. So either call by address mechanism or call by reference mechanism, you can call it. Okay. So there are two types of parameter passing mechanisms. One is call by value mechanism, and the other one is call by address mechanism or call by reference mechanism. Okay. Let us understand the first category of parameter passing mechanisms. The first one is call by value mechanism. So what will happen in call by value mechanism is, look at this example here. We have a calling function, that is f1 is calling the function f2 by sending two parameters n comma x, where n is an integer and x is a float variable. So while calling the function f2, so f2 is called here. While calling the function f2, we are sending n comma x. We know that n is a general variable and stores an integer value, and x is a general variable and stores a float value according to the declarations. Okay. Now, when you send values as actual parameters, then it is called as call by value mechanism. So I repeat, in function calling, if we send values as actual parameters, then the corresponding mechanism is called as call by value mechanism. So I can reveal the sentence here, call by value, which means call the function by sending values as actual parameters. That is the meaning. Okay, you can easily remember that. Call the function. Call by value means call the function by sending values as actual parameters. So that is what happens in the call by value mechanism. And when you send values as actual parameters, then the corresponding the corresponding function definition, the formal parameters should be general variables. Okay, so look at this. Because n and x are values, the formal parameters of the corresponding function definition should be general variables. So w is a general variable which is same as n here. N is integer and w is also integer, and x is float. Here also the name is x. Okay, so this should be the type of variable should be matched. And what you need to remember here in call by value mechanism is when you send values as actual parameters, to catch those values, formal parameters are also going to be general variables. General variables can hold values. Okay, therefore general variables are sufficient as formal parameters to catch the actual parameters that store values. Okay, so since n and x are values, w is a general variable, x is a general variable to catch these values. So remember this syntax. Okay, now let us go through this theory part, what it is saying to understand more about this call by value mechanism. Formally, in call by value mechanism, the values of actual parameters will be sent as the parameters in the function column. That is what we did. Okay, n and x are values, they are sent as actual parameters in function column. And the values of actual parameters will be copied to the formal parameters in function definition. That means n is copied to w, x is copied to x. Okay, so since they are copied, w and x acts as Xerox copies of these two values. And if you perform any modifications on w and x, since they are Xerox copies of n and x, if you modify Xerox copies, they will never reflect back on the original data. So if you modify this, the third point, the changes that are made to the formal parameters, that means any changes made to these formal parameters, w and x, will not reflect on the actual parameters n and x. Even though x, the name of variable x is used in both the calling function and called function, this x is different from this x. Okay, so in every function, you can have a variable with same name. So this x have its own memory location, and this x will have its own memory location. Therefore, any changes made on x and w will never reflect back on n and x. Okay, so it is only limited to f2 function only. So the changes made to w and x is visible for function definition f2 only. Within this function only it is visible, and the changes made over here will not reflect back to the actual parameters of the calling function. Okay, so this is what you need to understand. So that is the disadvantage of call by value mechanism. It is useful in situations where you don't want updations back to the calling function, and you just want to forward the values, and these values can be utilized by the called function but not changed by the called function. If you have that scenario, then you can go with call by value mechanism. Okay, but if you want to reflect the changes made to the formal parameters back to the actual parameters, then this mechanism will not be sufficient. Okay, so in such situation, we'll go to the next mechanism, that is call by address mechanism. Either call by address mechanism or call by reference mechanism, both are same. So what happens here is, look at this table again. In this case, what I'm sending is, I'm not sending n and x. Instead of that, in function calling, what is sent is address of n and address of x are sent. So instead of sending values, we are sending addresses. Okay, so since the actual parameters are addresses, the formal parameters should be pointers to catch these addresses, because we know that to store the addresses, you require a special variable called as pointer variables. Okay, therefore, formal parameters must be declared as pointer variables in order to store these addresses sent as actual parameters from the calling function. Okay, so if you understand this, okay, now let us go through these points. The call by address mechanism, basically the approach is addresses of variables are sent as actual parameters. Addresses of variables are sent as actual parameters. That is what we did. Okay. So these are the actual parameters. And if you observe, these two are addresses, not the values. Okay. If you send n, it means value of n. If you send ampersand n, it means address of n. So when you send addresses through the function call, that is as actual parameter, it is known as call by address because you are sending addresses. Okay, just like we revealed it in previous slide, call by address can be revealed as call a function by sending addresses of variables. You can remember like that. Call a function f2 by sending addresses as variables. Addresses of variables as parameters. Okay. Watch this. In the called function, pointer variables are used as formal parameters and stores the addresses of variables that are stored that are sent as actual parameters. What does this mean? These addresses, okay, so this ampersand n is an address. This address will be stored in a special variable called as pointer variable over here. So in function definition, that is in called function definition, you should use pointers to store these addresses. Okay. Similarly, to store the address of x, you need another pointer variable, uh, float star x over here. You can use any name here, but it should be a float pointer because it is a float variable, right? So that is the point it is mentioned here. And then the most important point about call by address mechanism is the changes made to the formal parameters will reflect back to the actual parameters. Okay, so what happens is reflects back. The changes will be reflected back to the actual parameters. That means if you change the value of the star w and star x here, the pointer variables, then whatever changes you make, they will reflect back onto n and x. Why? The reason is since w is pointing directly to n. Okay, so let me show with the help of an example here. So when you uh, so let us say n is storing some value. Okay, so n is declared over here, and n is storing some value, assuming that it is some 10. Okay, n is storing some value 10 here. Now n is having some address, right? Assume that the address of this n is 1000. Okay, so imagine that address of n is 1000. Okay, so now what we did, we are sending address of n, that is we are sending 1000, which is copied to w. Okay, so what is stored in w? W is storing the address of n, which is nothing but 1000. That means this address is a reference to this address of n. Okay, so what is done here is since w is storing 1000, it is a pointer to this location. So when you say w, it is 1000. When you say star w, if you say star w, it refers to what? If you say star w, it refers to the location n directly. Okay, so if you perform star w plus plus, let us say here, if you write star w plus plus, what will happen? Star w means value at the address 1000, that means 10. This will be incremented by 1. So this actually means that it is incremented by 1. Okay, that is it is changed to 11 now. 10 will be changed to 11. So if you update using star W, the change directly reflects on N because W is pointing to N itself. Okay. So that is the reason why whatever changes made through star W and star X, they will reflect back on N and X. Okay. So that is what you need to remember. So that is the difference between call by address and call by value mechanism. So you need to understand one point over here, uh, how the actual parameters are sent and how they are caught in formal parameters. And then second point is whether the change is made in formal parameters reflecting back to the actual parameters or not. So in call by value, the changes will not be reflected back to the calling function, whereas in call by address mechanism, the changes that we made will reflect back to the uh, calling function. Okay. Now let us understand this with the help of an example. So the best example to understand call by value and call by address is swapping of two variables. So what do we mean by swapping of two variables? Assume that there is x and y. There are two variables. In x we have 20 and in y we have 45 initially. And after swapping, the value of y should be copied to x, 45, and the value of x initially is 20. It should be copied to y. This is called swapping. Swapping means uh, copy the value of variables from one place to another place. That is mutually changing the values. That is called swapping. So for this, uh, first we will make use of call by value mechanism and see whether the values in calling function are changing or not. Then we also see how call by reference can be used to change the values uh, from calling function. Okay, let us go through the example now. Since the function is defined after main, it is declared over here. The function name is swap. It is not returning anything, and there are two integer parameters taken. Okay, so such a way this is declared over here, and in main function we are declaring two variables a and b. Enter the value of x and y we are asking. So what will happen with this is the a is created. Sorry for this. Oh, it's not actually enter the value of x and y. It is a and b. Okay, enter the value of a and b. Let me change it. Otherwise you will get confused. So enter the value of a and b, and then before swapping, the value is a is equal to and b is equal to. After swapping, the value is a is equal to and b is equal to. Okay. Yes. Now this is x and y. The values of x and y. Yes. Now two variables are declared here. Enter the value of a and b I'm asking. So scanf percentile d ampersand a comma ampersand b. So let us say that the value entered by the user is 45 into a, and the value entered by the user into b is sorry, a is 20 and b is 45. Okay, so imagine that situation where the values entered by the user are a is equals to 20 and b is equals to 45. Imagine the situation. Okay, right. Now before swapping, I'm displaying a message. Before swapping, a is equal to percentile d, b is equal to percentile d, a comma b. Okay, now these values a and b is actually 20 and 45 that will be displayed over here. So the message is before swapping A is equal to 20 and B is equal to 45. That will be displayed. And then I'm calling the function swap of A comma B, and using this function, the control is immediately transferred to the function definition. Therefore, it comes over here and starts executing the values by copying the value of A into X and B into Y. So now what will happen? X contains 20. See this diagram. X contains 20 because value of A is copied to X. A and B are different memory locations. X and Y are different memory locations. Value of A is copied to X, that is 20 now, and value of B is copied to Y, that is 45 now. Okay, so this is the scenario. And while executing, it declares a temporary variable. Okay, so a memory location with name temp is created. Then we are storing temp is equals to X. So what is the value of X initially? It is 20. So it is copied to temp. So now temp contains 20, right? And then X is equal to Y. So what is in X? It is still 20, right? So 20 is now copied to Y. Okay. Sorry. X is equals to Y. X is equal to Y means copy the value of Y to X. Copy the value of Y to X. What is the value of Y? It is 45. Now it is copied to X. So this is step 2. In step 1, what we did is copy the value of X to temp. So 20 is copied to temp. In step 2, we copy the value of Y to X. That is what we did. X is equals to Y. That means copy the value of Y to X. And then copy the value of temp to Y. What is the value in temp? It is 20. Now it is copied to Y. So 20 is into Y. Now if you observe, X contains 45 and Y contains 20. So now you can see that X and Y values are swapped properly. Okay, X and Y values are swapped properly. And if you display the message printf values of X and Y is percentile D, X comma Y, it displays 45 and 20 as an output. So within this function, it shows that the values are swapped. Okay, so once the function is completed, the control goes back to the function calling. That means it comes over here again and starts executing the next statement. Okay, so the execution again resumes over here. Now we are trying to display the message printf after swapping A is equal to percentile D and B is equal to percentile D comma A comma B. See what are the values in A and B? Is there any change? Because X and Y never contacted these memory locations. The values, these X and Y are local variables in this function. The values are changed in X and Y, but there is no reflection on A and B. Therefore, A still contains 20 and B still contains 45. So the message displayed is after swapping, A is equal to 20, B is equal to 45. So our motto is to swap the values in calling function, that is in main. We want to swap the values of A and B. That is why we call this function swap of A comma B by saying swap the values of A and B. But what happened is we are not able to swap the values of A and B. Instead, what happened is the values of formal parameters were successfully swapped, but the values of actual parameters are not swapped here. Okay, so that is the problem with call by value, and in some scenarios, this kind of actions are required. Okay, whenever you want to see that formal actual parameters should never be changed by the modifications made to formal parameters, then you can use call by value. Okay, but if you want to reflect the changes back to the actual parameters, then this method is not sufficient. Okay, so what we need to do is we need to use the uh, call by address mechanism to perform swapping here. Okay, so we'll see it now. Having seen the call by value mechanism and its drawback, we'll go through the call by address mechanism, how it can be solved, used to solve this problem of uh, swapping the actual parameters also. Okay. this is the example. Initially we sent 10 and 5 and it is still displaying 10 and 5 here. Okay, so after swapping also the values are going to be same. Now this is a program for call by address mechanism. Since we use pointers in formal parameters of function definition, the declaration should be void swap of int star comma int star. Okay. Now I'm using int a is equal to 10. So this will create two variables, a and b. Okay. So a is created. A is created and its value is 10. Okay. And b is created and its value is 20. Right. So two memory locations were created. Assume that these two are memory locations and these were created in the memory. Now it displays a message before swapping the values in main. A is equal to 10 and B is equal to 20. It shows the message as 10 and 20 before swapping. Yes, it is correct. Now I'm calling the function swap of &a comma &b. Okay. So with this function, the control transfers to the function definition and the address of a is copied to pointer a. You need to understand one thing here. A and b are local variables of main function and star a and star b are local variables to swap function. Those two variables are different and these two variables are different. Even if you change the names to x and y also, the same thing will happen. Okay, so now star a is created as a local variable to swap. So what will happen now? It's going to create a variable a that acts as a pointer to the previous variable a. So now this a is a pointer to the original variable a. So it points to a. Okay. Again, this b is a pointer to b. Whatever you do with these variables, they will be reflected back on the local variables of main function. That is what you need to understand, right? So we are again seeing a temporary variable. Temp is equal to star a. What does star a mean? A means address of the local variable of main. Star a means it refers to this location. So the changes are made over here. So what are the changes here? In place of this, temp is equals to star a. That means 10 is copied to temp, right? So 10 is copied to temp. So now there is a variable temp which stores 10 because star a is 10. A is 10 and star a from here is 10. So from swap function, star a refers to value 10. Star b refers to value 20. So temp is 10 now. Okay. Then what is the second step? Star a is equals to star b. What does this mean? Star a is equals to, that means you are going to change this 10 over here. Okay. So you are going to change this value. In place of 10, what we are copying, it is star b. What is star b? From here, star b is 20. Okay. So this 20 is now copied to a. Okay. So now you can see this gets a value 20. Right. So now a is getting a value 20. Again, what is the next step? Star b is equal to 10. So what happens now? What is star b from here? It refers to 20, this location. So this is now changed to the value of temp. What is the value of temp? It is 10. So it comes over here. So into b, the value now is 10. You can see that the values of local variables of main is getting changed. Now the value of a is changed to 20 and the value of b is changed to 10. Here I am displaying a message after swapping values in function a is equal to %d, values in b is equal to %d. What is star a from swap? it refers to this value. What is it? 20. So it displays 20, and star B refers to B is here. Star B refers to the value in B of main function, that is 10. Okay, so displays 20 and 10. This is in swap function. Once the program completes the execution, that is function completes the execution, the control from here goes back to this location. Okay, again it comes over here and starts executing the next statement after function call. What it is saying now, printf, after swapping values in main, a is equal to %d, b is equal to %d, comma a comma b. So what is the value in a? It is 20. What is the value in b? It is 10. Now the values are swapped, we can observe that. Okay, so in main function also the values reflected, the swapping reflected, and in function, general function also the values reflected. How is this possible? With the help of call by address mechanism or call by reference mechanism. Okay, so it is clear now that in previous call by value mechanism, we are not able to update the values of actual parameters, whereas in call by address mechanism, the actual parameters also reflected the changes. Okay, so whenever you want changes to be reflected back to the actual parameters, then use this call by address mechanism. Otherwise, call by value mechanism is sufficient. Okay, so I hope you understood now the two parameter passing mechanisms. You need to practice these two programs. The best example for call by value and call by reference mechanism is a swap function. So please practice this example program. Okay, you can see the example here. Before swapping the values in main, a is 10, b is 20. After swapping values in function, a is 20, b is 10. So in function, it is swapped. This is done in call by value also, but we are not able to do this. There it displayed as a is equal to 10 and b is equal to 20. But if you observe, in call by address, a became 20 and b became 10. Okay, so this way you can make use of call by address mechanism. Right. Now, another important topic that may come in our examination is types of functions based on arguments and return types. We have seen classification in our first class of functions, that is two types of functions called as library functions and uh, the other category is user defined functions. And this is another classification which is based on the arguments and return types. Okay, so this is another important theory question you need to understand. You need to read for examination point of view also. Okay, so we can classify the functions into four categories based on whether return types are there and arguments are there or not. Okay, so the first category is function with no return type and function with no return type and no argument. Okay. Both are not present. Return type is not present and argument is also not present. So here it is function with return type. So second category is return type is there, but there are no arguments. Okay. And the third category is there are no return types, but it has arguments. And the last one contains both return types and arguments. So if you observe, the first one has two no's, that is no return types and no arguments. The second one has one no with respect to the arguments, but it has return types. The third category is functions with no return type, but it has arguments. And the fourth category contains both return types and arguments for the function. We'll see now with the help of examples how these can be declared and defined using some syntaxes. Okay. Let us start with the first category, functions with no return types and no arguments. Have a look at this calling function and called function. I'm using F1 as calling function in which F2 is called. So if you observe this called function, there are no parameters here, no parameters. And if you observe in called function, See this void. Void means that there is no return type. Okay. So in called function, function definition shows that void means there is no return type, and empty parenthesis means there are no arguments. Okay, so our category is no return types and no arguments. So function definition contains void as return type since there is no return type, and function uh, contains no parameters is represented as empty parenthesis. Okay, so in such scenario, while calling the function, you don't need a variable to catch any value because it's not going to return any value, and the parameters part is also empty. Since we are not sending any parameters, parameters acts as input, so no data as input and no data as output from the called function also. Okay, if parameters are there, it means there is some input. If you are returning some value here, then it means there is some output back to the calling function. So in this scenario, uh, we have no return types and no arguments. Therefore, there is no input data and there is no output data. Okay. The second category is functions with return types and no arguments. See this, there is some return type. It may be any valid data type in C language, such as integer, float, char, and so on. And if you observe, there are no arguments. That means empty parentheses. Okay, and you will write the code, and at the end of the code, you should return some value which matches this return type. Okay, so because uh, uh, it is returning a value, this returned value should be caught accordingly using a variable here. Therefore, the syntax in calling function should be variable is equal to function name, because there is some output produced by the function f2. And since there are no parameters, it means there is no input data to the function. Okay, next. The third category is functions with no return types and with arguments. That means return type is not there, but arguments are present. Okay, so if you observe, since there is no return type, we'll show it as void. Function name is f2, and because there are parameters, we'll show them as data type followed by argument 1 comma so on. You can have any number of variables here along with their types. Since there is no return type, you will not use any return statement here, and therefore there is no output from this function. Since parameters are sent over here, it means there is input in the form of arguments. So all these arguments are copied to this formal parameters. Okay, the number of arguments should be same as the number of formal parameters, and the type of each argument should be same as type of formal parameters. You need to remember that, right? So in this third case, we have input data sent to the called function, but there is no output produced by the called function back to the calling function, right? And the fourth category is functions with return type and uh, arguments. Both are present. Okay, so you can see it here. There is return type and there are some arguments. Since there is return type for the function f2, you should return a value. This return value should be same type as this return type. Okay, and because this function is producing an output, there is some data as output back to the calling function. Therefore, you should use some variable on left hand side of assignment operator to catch the value returned by this function f2. Okay, so this value is going back here. You should use some variable to catch that value. Okay, since we have arguments also, parameters must be defined here, formal parameters. Again, the same rule is going to be satisfied. All the arguments, that is the count of arguments, should be same as count of formal parameters, and the type of argument should be same as type of uh, arguments over here. Since we are passing arguments here, the input is in the form of arguments. The data is sent to called function. So the data is flowing in both ways now. We are sending arguments to the called function, and we are getting values result from the called function also. Okay. So this is the fourth category. Right. So that is what I wanted to discuss today. So what we discussed today is we discussed about the parameter passing mechanisms used in functions of C language. There are two types, call by value and call by address mechanisms, and we have gone through some examples to understand how they work and what are the advantages and disadvantages of both the types of parameter passing mechanisms, and where to use, in which scenario we need to we will use that call by value and call by address also. And then we have discussed about four categories of functions based on whether return types are there and arguments are there or not. Okay. We have gone through some examples and syntaxes also to understand these categories. These two questions, especially parameter passing mechanisms and types of functions based on return type and arguments. These two functions are extremely important for your examination point of view. So watch this video again and again until you understand the topic. Okay. So if at all you got any doubt, you can contact me over my phone or you can mail me. Okay. That's all for today. Thank you all for your patient listening. We'll continue the topic of functions in our next class also with a few more example programs and the remaining topics. Thank you all once again.